Hi everybody. Here are your notes for 8.2, factoring trinomials. I know this looks a little scary maybe here, reading across the top of it, but hopefully I give you plenty of practice problems. We're actually going to do this note sheet over 2 days, so right now I'm going to tape for you the first day of notes, and then I'm going to do the second day as well. So this will be over 2 days. But here are your notes for day 1 of 8.2, factoring trinomials. So we have pages 202 to 205. So you should probably open up your textbook to those pages as we go. You can go ahead and fill in the date up here with today's date. So factoring is this. Factoring is working backwards. It's taking the answer and finding the binomials that we use to find those answers. So you can see we have, here in my example, I have factoring, and I can see I've got an x squared and an x and a constant term, like a polynomial. I can even jot that down there for you. We're going to take that polynomial answer and turn it back into the things we would have FOILed or box method in order to get that trinomial answer. So we're working backwards today. Our form is going to be ax squared plus bx plus c. That is super important for you to memorize and know and write down. It's going to be all over everything today. And if you can see today's notes, I have a equals 1. So this number here today is always going to equal 1. That's in front of the x squared. It doesn't always have to be 1, but to start, we're going to have it equal to 1. On the bottom of your note sheet, you should have some example problems. Those are for your reference later. I'm not going to go through them right now, but they are for your later reference. So here we go. I'm going to show you how to do this. First page of notes here is what I just said, and if you want to copy this, you can. Pause at any time. To factor is to find the two binomials that were multiplied together. This is the opposite of the thing we did in the last chapter. So now we're going to take the answer and go back to the multiplication problem. Our form is always going to be ax squared plus bx plus c. So you're always going to have the squared term and then a term that is to the number 1. So I'll stick a 1 in there. It's not to the 0. And then a term with no variable, just an integer. And today, the number in this a spot here is always going to be 1, just for today. Later on in this chapter, we're going to go and make those actual numbers and factor. But it's easier when it's just a 1. The rules, and this might not make any sense right now, and I'll do a whole bunch of problems for you, 6 today, in fact, to make this make sense. The rules are, or I guess it's one rule, it must multiply to AC and add to B. So let me get rid of that 1 I wrote on there. So it has to multiply to whatever A times C is, and we would multiply those two together, and then the numbers that you multiply also have to add to the number that's in the B position. It sounds complicated. Hopefully this all makes sense. All right, here we go. Problem 1. I wrote your form up here for you. The first thing we should do is double check that it's in the right order. I have an x squared and a squared. Good, that's the first term. I have just an x here, and I have just an x here, and I've got an integer and an integer. So we've got all the things in the right order. Let me get rid of my little dots I just made on there. All right, so we have to find the numbers in the A and C position. In A, there's a number 1, and in C, there's a 22. So I always multiply A times C. When I write them next to each other, that's multiplication. Well, A times C, 1 times 22 is 22. I now want to find all the factors of 22. All the multiplication problems that multiply to 22. So I have 1 in 22, 2, and 11, and I think that's it for all my multiplication problems. Those are my choices for my binomials, either 1 and 22 or 2 and 11. Okay, well the rule was it has to multiply to AC, but it also has to add to B. So when I add these things together, I have to figure out how I make 13. Well, if I do 1 plus 22, I get 23. That's not 13. But guess what? 2 plus 11 is 13. It multiplies to 22 and it adds to 13. So the numbers I'm going to use are 2 and 11. All right, so what do I do with those then? Actually, this part becomes rather easy. I'm going to leave a spot for 2 binomials here. This is going to be my final answer. My variable I used was an x, so I'm going to throw an x here in each binomial. And then I go back and look, I have a 2 and an 11. So, and it doesn't matter actually which order I write them in. I put a 2 in one binomial and an 11 in the other. And because they were both positive, they become plus signs. Now, how can I check that that equals x squared plus 13x plus 22? You can go ahead and do the box method or FOIL to double check. So let's box it. X and 2 and x and 11. X squared, 2x, 11x, 22. These terms are the same, remember, so I have x squared, 13x, and 22. That is the correct answer. So the answer you would write for this problem is x plus 2 times x plus 11. Pause it at any point in time. Next problem. All right, I wrote your form for you up at the top again. Ax squared plus bx plus c. I first check the squared term, the regular variable with no squared on it, and the constant. Looks good. Notice I went to number 3. I know I skipped number 2. There was a reason. I'd come back to 2, but not yet. All right, so it has to multiply to whatever's in the A and C position. Remember, there's a 1 here. So in the A position, I've got a 1, and in the C position, I've got a negative 20. 1 times negative 20 is negative 20. So multiply A to C to get me negative 20. All right, now I'm going to forget that it's negative just for a second. All right, all the factors of 20. 1, 20, 2, and 10, 3, no, 4, and 5. Those are all my factors of 20. That number in the B position is also a 1. So remember, they have to multiply to A, C, and add to B. So I need to find something that multiplies to 20 but adds to a 1. Okay, I have a negative here though. So to be negative, one of my 2 terms has to be negative. So if I think of 1 and 20, if I make this one negative and 20 stays positive, because negative 1 times 20 is negative 20, then I would get, if I added them together, a positive 19. But if I make the 20 negative, I would get a negative 19. Neither one of those adds to 1. All right, so let's make the 2 negative and the 10 positive. That would give me 8. If I flip it, it will give me negative 8. That doesn't work either. So let's say I want to make the 4 negative plus 5. That's 1. That's what I'm looking for. So my answers are negative 4 and 5. Now if I did it the other way, I made the 5 negative, I get negative 1. But remember, I wanted to make positive 1. All right, so what do? I now know I need to do negative 4 and 5, and this time my variable was an n. So I put n in my binomials, and this time, since my 4 was negative, it's minus 4, and my 5 positive, so it's plus 5. There's your final answer. And now I'm not going to check it, but just to keep going, or when you do your homework, you should FOIL that or box method it to make sure that it equals the original problem. Problem 4, which is really problem 3, right? All right, I see a problem with this one. It is not in the proper order. I have d squared, and 28. I need to fix that. d squared should be my first term, and then I should have 16d, and then I should have plus 28. All right, first and foremost, we multiply a, which is 1, and c, which is 28. So that's 28. So that's AC is 28. All right, now we need to write all the factors of 28. 1 and 28, 2 and 14, and 4 and 7. All right, we needed to multiply to 28, but we needed to add to 16. So, and no, it's not negative, it's positive 28, so I don't need to throw a negative sign on any of these. So looking simply at these factors, you need to find the one that adds to 16. Well, this one adds to 29, this one adds to 16, and this one adds to 11. So the winner is 2 and 14. So I just write my binomials. This time I use D in my problem, not X. All right, doesn't matter in my order. I can do 2 or 14 first, but since I wrote 2, I'm going to do D plus 2 because it was positive 2, and D plus 14 because it was positive 14. There's your final answer. 2 problems to go. Now I'm going to pop back, I think, to number 2. Maybe 3 problems to go. I don't really remember. And we are going to factor this one. So it's in order: squared, regular term, integer. I need to multiply AC, so that's a 1, remember, and a negative 20. So A times C, 1 times negative 20 is negative 20. Let's go ahead and write all the factors. I have 1 and 20, 2 and 10, 3, no, 4 and 5. There are all my factors. Hold on 1 second. I just realized I wrote the wrong problem there for you guys. So, now that you've listened to me ramble, we already did this problem. Can you totally erase this and let's write the right problem down? Mistakes even happen when you're not here. It is y squared. Okay, so it'll be in order. Minus 3y minus 2. So if you were thinking she's crazy because we already did that problem, you were right. Let's do it again. Multiply what's in the A position and in the C position. So I have 1 times negative 2. That's negative 2. So A times C is negative 2. Let's write all the factors of 2. 1 and 2. Well, that was pretty easy because those are the only factors of 2. 1 times 2. I need that to add to negative 3. So being very careful, I got to get to negative 3. Okay, well, to multiply to negative 2, I can either make it be negative 1 and positive 2, that'd be negative 2. And if I added those, that would give me positive 1. Or I can flip them, because remember I need to be a negative number, so positive times a negative is a positive, or it's negative 1. Here's my problem. Neither one of those adds to negative 3. So when this happens, and this is kind of our exception to the rule, we say that this is prime. It is already in lowest terms and it cannot be factored. So if you find, after looking at all the factors, they do not add to B in any way, shape, or form, it becomes a prime polynomial. All right, let's see if I wrote the next problem right. It should be number 5. I did. All right, so number 5 is negative n squared plus 10n minus 21. You should see something weird right away in this problem. First of all, it's in order, but I have a negative on my problem. So when I have a negative in the A position, that's not allowed. So what we're going to do is we're going to pull that negative off. And if I pull it off, I flip the signs of everything inside. So I have n squared minus 10n plus 21. All right, so forget the negative on the outside for a moment. It goes on my final answer. We're just going to factor the stuff inside. So I have a 1 in the A position and a 21 in the C position. A times C, 1 times 21 is 21. The factors are 1, 21, 3, and 7. So I needed to add to negative 10. Now that's a little weird because 1 plus 21 is 22. And 3 plus 7 is positive 10. But we can do something to this problem. And we could, in theory, make both of these negatives because remember, a negative times a negative is a positive. So if I make them both negative, I would get negative 22. But if I make both of these negative, negative 3 times negative 7 is 21. But if I add them, it's negative 10. Hey, I found the things that add to negative 10. All right, so I use n as my variable. And I have negative 3 or minus 3 and minus 7. Now don't forget about this negative sign. It just slaps right on the outside of your answer. And I get that is my final answer. All right, one more problem. Last one. I ran out of paper. I wrote you so many problems. All right, p squared, 5rp, 24r squared. I will immediately tell you that this is in order. ax squared plus bx plus c. I totally get that there is an r squared, a squared attached to this, but please note there is also a squared here, and I told you today that a is 1, so that p squared is going to come first, and I know that's a little weird, and this is kind of like our challenge problem for the day, so let's figure out if we can do this. So let me do a little erasing here. It is in order, so let's erase, and let's figure this out. In my A position is still a 1. In my C position is this whole term, okay? 1 times negative 24r squared is negative 24r squared. So I need the factors of negative 24r squared. Forget that it's negative for a moment. Let's just do the factors of 24. 1 and 24. Now, how do I get r squared? They each have an r attached to them. Okay? 2 and 12. R times r would be r squared. 3 and 8. Right? Yeah. And 4 and 6. Now, this is negative 24, which means that one of my terms has to be negative, and we need to add to negative 5. Forget the p. It'll make sense in a moment. Let's just figure out which one adds to negative 5. So as I look through these, I know this one is not going to do negative 5 for me, no matter where I put the negative. This one is not going to make negative 5, and this one is not going to make negative 5. But 8 and 3 have a difference of 5. So now this was negative 24, so I have to make one of the either the 3 or the 8 negative. So I want it to be negative 5, so I want to throw that negative on here because negative 8 times 3 is negative 24, and negative 8 plus 3 is negative 5. So those are the two I'm going to use. In my binomial, I used p as my variable. And I'm going to put in plus 3r and minus 8r. Now I want to prove to you that this one equals that actual answer. So I'm going to box method this last one for you. Let's do the box method. So I have p and 3r and p and negative 8r. So I get p squared, and I get 3rp, and I get negative 8rp, and I get negative 24. R times r is r squared. So my final answer would have been p squared minus 5rp minus 24r squared. Let's just go back and double check because I'm off the screen now. 5rp in the middle, negative 24. Yep, we totally got it. So this, friends, is your final answer of your binomial. Go back and watch this video as many times as you need, please. If you need anything, feel free to call, text, email, Zoom me with questions. If you want a conference call, let me know. Otherwise, good luck with the homework and more to come.